Hello dear learners, welcome to this video. Here we are looking at a paper 1 question under physics, which is science paper 1. So the question says the following diagrams show an unstretched spring of 10 centimeter. So this is the spring unstretched and it is 10 centimeter, and the stretched spring, which is 22 centimeter, with a force of 4 newtons hanging. So what the question wants us to do here, it's a case whereby the spring here wasn't stretched and then it's stretched. Okay, so let's look at what the question wants us to do. So the question says calculate the total length of the spring when a force of 6 Newton is applied. Okay, so here's what we are going to do. Let me take this question here. So here's what we are going to do. So we are trying to find another scenario now where they changed this force. Okay, so meaning we have something else again here. We have another spring there. We just try to roughly draw it, and then so now this one should be longer than the other one, because the force that is applied here, it is 6 Newton. Okay, it is 6 Newton. So we're saying that we have a 6 Newton force. Okay, so 6 Newton. So now what will be the total? So we are just trying to find the length now. The total length from here, okay, all the way up to here. Okay, so we want to find the length now, all the way, okay, from here up to there. So we are just going to call it h. Okay, it's the height. Right, so what we're going to do here, we need first to find, we must use the formula. The formula is given as extension 1 over load 1 is equal to extension 2 over load 2. So what we are going to do, we can call this as load 1, this one as load 2. Then we can find extension 1 from this. So extension 1 here will simply be, so extension is something that's been added, meaning it wasn't actually there, but then it has just been added. Okay, so extension 1, we can simply find it, extension 1. So we're going to say it's equal to, the original spring was 10 centimeter, but after adding the 4 Newton, it extended up to 22 centimeter. So we're going to subtract 22 minus 10 to find extension 1. Okay, so 22 minus 10, this will give us 12. Okay, 12 centimeter. So if we change this to meters, it will be 0 let's see, 2 meters, that will be 1 2. Okay, so 0.12 meters. Okay, so now our job is just to find extension 2, and then to help us now to find this. So using this formula here, extension 1, we've said it's 0.12 over load 1, that is 4 Newton, is equal to extension 2. We are just going to say extension 2, load 2 there is 6 Newton. Here we can do simple mathematics of cross multiplying. 4 newtons times extension 2 this will actually be extension 2 4 Newton, and then this side we are now going to multiply 0.12 multiplied by 6 Newton. Okay, so that's what we are going to do. Okay, so 0.12 multiplied by 6, okay, we get 0.72, so 0.72 this times this, then we can say divide by 4. Okay, so this will go, so you say extension 2 is equal to, divide by 4, we get 0.18. Okay, so 0.18 meters. So now this now is the extension 2 here, how long it will be extended. Okay, so when we take this to centimeters, we are going to say that extension 2 is just 18 centimeters. Okay, 18 centimeters. Okay, so now this is not the total, they said the total length, so we can now say the total length now, total length will basically be extension 2, which is 18, plus original length of the spring, which was 10, and this will give us 28 centimeters, and this is our answer. Okay, so that is how you can answer this question. Okay, so if you haven't understood, leave your questions in the comment section and you can replay the video as much as you can. So for those watching this for the first time, click the subscribe button and also like and share the video as well.